Okay. Can you hear me? Yeah. Okay, I want to start. Hi, my name is Gilad. I work for Red Hat. I'm a co-maintainer in the oVirt project, and I'm working for the SLA and scheduling team. Today I'm going to talk about VM scheduling within oVirt, how it got evolved, and etc. Basically, we'll talk about the problem of scheduling a little bit, then we'll go ahead and talk about Nova filter schedule concepts, and then we'll deep dive into oVirt scheduling, giving a lot of samples. I think the best way to understand stuff are through samples. Okay, can you raise your hand if you heard about oVirt? Yeah, I guess a lot of you are. It's a home crowd. So oVirt, for those of you who don't know what is oVirt, oVirt is a management platform for VMs based on KVM hypervisors. Can handle thousands of VMs, has live snapshot, live storage migration, live VM migration, live, everything is live basically. And we support also advanced network configuration for those hosts and a lot of storage connections, SUN, NFS, Gluster, etc. Basically, let's see what we've got. A long time ago, we got the questions from the users list. I urge you to use that list if you have any questions about oVirt. It's quite, it's quite active. How can I define a maximum number of running VMs per host? It's pretty trivial, but we didn't support it that yet then. So we get back to it later. I just wanted to say that you should use the users list. Okay, what we had in oVirt a long time ago, basically we had two distribution algorithms for running and migrating VMs. When we selected a VM, when we ran a VM, then we selected a host based on CPU load policies, either even distribution CPU load or power saving, and then it's pretty, limited. We have only two distribution algorithms, and we can't construct a user-defined one. Basically, that is it. Then we take a look. We looked at the Nova scheduler, which brought us filters and weights. Very simple and easy way to filter to schedule VM on hosts. Basically, the filters are very cut and clear logic that gets a set of hosts on the left-hand side. Then we run a filter on them. Then we apply weights on top of them. Another cool slide from Nova Scheduler. We collect a set of weights, then we sum them up, and then we order the host that we got. Let's see a simple sample for Nova Scheduler. This is a RAM filter written in Python. Basically, it's a very simple method that gets a single host data and a set of properties, and then run really simple code that either decides if this host is in the scheduling process or excluding it from the scheduling process according to the requested RAM for that VM. Okay. When we looked at that and took it to the data center virtualization, which is oVirt, we saw that we have a little bit of problem with that concept, because In Nova, each filter and weight is applied on a single host, and we have a larger concept of clustering in oVirt, which is called migration domain. So in the migration domain, each VM on a host can be migrated to a separate host on that migration domain, that cluster. And we have another concept of load balancing for that cluster. And also a policy container, which a user can decide and create its own policy and apply that on that cluster. So let's take a look what we had in oVirt. Basically, we can create internal and external filter and weights. The internal part is used for better performance. We are within the server, so we get a quick access to the DB. And originally, all the filter and weights from the previous oVirt back then, when we didn't have filters and weight, were migrated into that internal scheduler. And the external that basically all the users can support and extend. We apply all the filters, we apply the filter and weights on all the hosts in the cluster for better performance, and we want to have a better grasp of how the cluster behaves. We have containers, we call cluster policies. For each cluster, we can define the set of filters, set of weights, and a single load balancing per each cluster. And then we support custom properties that you can, it's kind of pass through to the filter and weight. This is a diagram of the new model. On the left-hand side, we can see a set of hosts within the cluster. Then we apply each filter, chaining each filter one on top of the other. And then we construct a weight table, which gets us the result of the selected host that we want to schedule the VM on. We had the same concept as Nova and filters. The existing logic that we had previously, which were basically validation, was migrated into internal filters, and we can extend it using in Python using the external scheduler that I will get into later. I want to show you a really easy sample of how we can use filters. Basically, this is a filter in Python. The name of the class will be the name that the server gets. The properties validation are basically a set of property that you can add within the server, and then the filter will get it. This is the name of the filter, and this is actually the signature that you need to override in order to extend a filter, to add a filter to the system. This is how you get the custom properties from within the filter. Basically, I didn't tell you what the filter is all about, but here you can see we get the time, and if the time is within the interval that we get from the user, then we print the host. We return all the hosts that we got. If not, we just exclude all the hosts from the filter. That's kind of a bank example. Okay. Let's talk about the weights. It weights all the hosts that pass through the filters. We have the predefined weights. That the first two are CPU load filters, and then in 3.4 we added a lot more weight models. I said filters. Weight models, which is kind of easy now to add because we had the new architecture. Each filter can have factors. We can prioritize the filters. Each weight can have factors. We can prioritize the weights using factors. We can also add external weights. Let's see another sample. In this sample, we use a connection to the server using a Python SDK that we have. This SDK is backward compatible and stable. We connect to the SDK, and then the logic of the weight is basically we iterate over all the hosts, and we append to a list a tuple of the host ID and the weight of that host. Here it's a little bit cut, but the weight of the host is the number of active VMs on that host. So if we have a host with, basically it will be ordered by a number of running VMs within that host. Let's continue. Talk about the load balancing. That's the third model we have in the cluster policy. Each cluster policy can have only one load balancing logic. Basically, you can do whatever you want within the load balancing, connect to the SDK, and you can shut down everything, basically. But what we support internally is that the load balancing logic will return a VM and a set of hosts. I will show it in a sample later on. And we will migrate that VM, a single VM within the server. It's basically more safe to migrate a single VM within, a period of time, not to cause a migration rush and, use all our resources for that. It's pretty not safe to do that. We also have a predefined load balancing within oVirt. The two legacy ones on CPU, and now added in 3.4, even distribution one even VM distribution that we didn't have. The same balancing sample that I want to show, as I showed earlier, is we get the same numbers that we want to shut down all the VMs, but in this example, we will actually do that and not exclude hosts that prevent users from running host VMs like in the filter example. Here we will show how in that hour, in the wake-up hour, we will basically get all the hosts, and if it's wake-up hour, we will activate all the hosts. If we need to sleep, and then we will connect using our SDK and get all the VMs from that host. We will stop all the VMs and we'll deactivate the host. Same bank example. This is how we use it internally to migrate VMs. You get, according to some logic, you get the overloaded host. It's a code snippet. Then you select, here it's random, the first VM on that host. Then we actually print it because we're using stdio to get the data from the module, and we return it, and we return a right listed host, which is kind of a filter. The first filtering we do before we activate the filter and weights and the normal process that we do. Basically, as I said, we have a cluster policy, which is a container for all the filters and weights and a single load balancing logic. And we have two optimizations for our cluster policy. Speed and overbooking. Basically, we run each time we schedule a VM, we run it one by one because we want to prevent overbooking the same. We want to guarantee the same resources for each VM. If we will try to schedule two VMs together, we can fail because they both see the same resources. So basically, the speed optimization is to exclude the weight of the hosts. So later on, the load balancing will do the weighing for us and balance out the cluster for us. And the overbooking is to emit just be able to parallelize the scheduling process. Let's see if we can show those pictures within oVirt. Okay. No. Okay, this is oVirt. The VM is, because of Wi-Fi and VPN, the VM is unknown. It's running somewhere. Okay. Here I configure, that's it. Here I can configure a new cluster policy. Can give it a name, like the shutdown one. I can add the external filter that I've added to the system, the shutdown host filter, to the enabled filters. As a weight, I will give optimal for power saving. That's try to aggregate all the VMs within a single host as much as possible. Then I will select the balancer that I created earlier. I can give it wake up hour like 8 a.m. and shut down hour at 8. Press OK. Should be created. Okay, I don't know what happened. Second. What? Okay, let's go back to the...
It takes some time, absolutely.
No, it shouldn't take some time. What? Yeah, I'm not connected to the VPN.
It talks about some time.
No, something happened to the VPN. Doesn't like me. Yeah, I have screenshots, but maybe it will work. Second. Okay, let's take a look at the screen. It works, believe me. Okay, we were here. Wait a second. I'm connected. No, still no. Never mind. I will show you that one. Then you go to cluster. No, still not working. Okay, forget about it. Okay, I create the cluster policy that I've showed you. Then I created to a cluster that I already defined, so all the hosts within that cluster will act according to that cluster policy. Okay, let's talk about how it's implemented in the back. It's disabled by default. Whoever wants to extend, to add filters should be able to know how to install the external scheduler. The external scheduler is a separate process written in Python. We externalize it because we want to guarantee the engine safetiness. You know, if a user writes a code, it can be dangerous to the system. We want to allow other languages as well. If you know, the oVirt is written in Java. So, and this model is written in Python. And going forward, we want to support SAS, which is kind of a scheduling as a service. Yeah, that's what it is.
Wow.
Oh, well, yeah. It's a separate RPM. You need to manually install it. How it works, basically it's initialized. It reads from a local directory all the filters, weights, and balancing logic that you wrote. Then it's published in an internal API. The engine, the server, reads it, and then it waits for calls from the engine for filtering, weighing, and balancing. This is how it looks like when it's loaded, the filter and load balancing here. Okay, back to the users list. Now we can easily write a filter that maximizes the number of running VMs per host. Okay, pretty early. Okay, to sum it up, we support easy Python plugins for you to use for VM scheduling. You can manage a separate policy per each cluster, for each group of hosts, and every version that comes out for oVirt gets new modules for scheduling. Questions? Yes.
So the question is that I have the possibility to read from what the hypervisor provides, memory utilization, CPU utilization.
Yeah.
Since you have a Python extensive API, if I got it right,
Yeah.
you may have the possibility to know if the storage behind or the storage framework behind is constrained. So you have the possibility to say, all right, do a storage migration, these virtual machines to the other storage, which is SSD based or whatever.
Yeah.
So you just need, for example, to have a good talk with all the storage big guys and find more things about their IOPS and what we are doing on their storage.
Yeah.
To get that information, right?
Basically,
Yeah, because we have the memory, we have the CPU, maybe we have some network information about throughputs and stuff.
Yeah.
So what's left behind is the IOPS and the quality of the storage.
you can think of whatever, you know. You all heard a question? I think so. Yeah. I think within, you know, when you extend. Okay. You can do whatever you want when you extend, you know, a filter, or when you basically can connect to every provider or use any SDK that you like. So what we provide within the engine is all that you ask, you know, memory and CPU load, and if you want to connect to other external provider, that it's your own choice. Did I answer?
Hi. So we had a few guys in the oVirt workshop in Bangalore, and they were asking us to connect the scheduler to a BMC system that is monitoring extra parameters. For example, they can monitor the CPU temperature and the fan speed, and they can actually predict that if the fan speed is constant or 0 and the CPU temperature is high, that host is going to crash and burn in a few minutes. So what they asked from us is to give them a list of hosts, and they can actually blacklist some of them because they are aware of more information than what oVirt should have. And there are so many other examples which are very similar. For example, Cisco has very similar concepts. They actually want to blacklist some of the hosts because the networking is going to go down there. There are a lot of very similar scenarios. In very big enterprises, this is actually highly wanted.
Absolutely, sounds promising.
Yeah. So now you have the power. You can actually do it yourself.
Well, my first idiot simple question was, all right, I know about my CPU, my memory. Maybe I know about my networking because we do the networking. So the next good thing is if I had the storage I/O information or information that had to do with the quality of my storage, perhaps I could utilize multi-tiering in a storage or storage we motion a virtual machine from one place to the other. That could be nice with this engine.
So there are endless use cases of this mechanism. That's all openly in the infrastructure, so everyone can actually implement this open use case without the need to modify all over for that. So sometimes some organizations have provided a network, we can't really
More questions? I think we're done early. Go drink a beer. Thank you.
Thank you.
מה שאמרת לי, הייתי אומר לך, לא לחשוב על זה.
לא, זה בסדר, כמה בזבזתי 10 שניות. ראו את זה.
שזה נראה באמת? רואים שעון מסתובב, לא יודעים שזה
זה עבד לי מחוץ. כן.
אם זה היה, אתה יודע, רץ לסמק בלפטופ.
זה מה שחשבתי שאולי אתה מעיף של מהלפטופ.
כן, לא יש לה...
Thank God I'm over it.
No, it's fine. There's the part I saw. I didn't see it in time, but the part I saw it was fine.
Okay, should I? Or
Yeah, like put it quite close because it's not. It doesn't have a lot of gain.
okay.
The 6 of the spot. Or
I think it's 20 past 6 my talk. If I'm not
okay.
wrong.
Okay, so
The last one finished earlier.
yeah. So if you want,
Test.
we can mute it. Or
Yeah, it would be better. Okay.
may have to move the mic.
So test. Can you hear me? Is it okay? Perfect. Okay. So, welcome everyone.